Hi, everyone. My name's Dr. Smith, and we're coming to you from the Roar Room here at Penn State to talk a bit about two of the engineering departments that are not actually in the College of Engineering. So I'm an assistant teaching professor in material science and engineering, and I'm here with
Eugene Morgan. I'm the associate head for undergraduate education in the Department of Energy and Mineral Engineering.
Well, I guess, before we talk about where our students frequently go and what they do with their degrees, I'll talk a bit about how I actually ended up in material science and engineering in the first place, because it's not a field that a lot of universities offer. It's really at a lot of more specialty universities and really big schools like Penn State. So I did my undergraduate degree at University of Maryland, Baltimore County, and I got a degree in physics and math. So I started out very much on the natural sciences sort of things. And I ended up doing my PhD here at Penn State in material science and engineering because of an internship I did while I was in undergrad. So I worked for the National Institute of Standards and Technology in what's called the SURF program, which is like their summer research fellowship kind of thing. And I worked with some material scientists, and I found that it was really interesting. And so I decided to do that in graduate school, and that's when I kind of shifted more to the engineering side personally. About how you ended up in yours. But.
Yeah, it's a long story. So I started actually in geology for undergrad, but after that did my master's and PhD in geotechnical engineering. So it was an easy transition into that form of engineering. And, that's carried me on into academia. My undergrad experience and grad experience, I really admired what other faculty were doing in that, and in terms of mentoring me, but in giving me opportunities. And so academia was a very attractive place to go after that. So after grad school, I taught at Duke for a little bit and then wound up here, and I've been here for 12 years. So, well, should we rewind to the basics? Like what would you say engineering is?
Engineering for me, I think, is really all about sort of, fundamental design and optimization of different devices and processes. Yeah, I think it's all about designing and optimizing, different structures, devices, processes, things like that.
Yeah, great. Yeah, and more generally, I see engineering as applied science and math.
Yeah.
Like if we're talking about all the engineering disciplines in one, kind of one theme is that you're taking scientific principles and mathematic principles and applying them to, as you said, the design and optimization of things, right? And I think your department embodies this really well in that you do have science and engineering, in the same.
Yeah, I think we're a very strong mix of the two, right? So what attracted me to material science and engineering is like, well, I can get this degree and I can just go take a physicist job if I want to still do physics, right? It's materials are in everything; they're everywhere. So it had a lot of the advantages that I was looking for, where I could still do fundamental physics and chemistry, but it also opened up all these new options of the more applied side.
You touched on a good point there that, materials are everywhere. And, in terms of, what engineering is in practice and in society, I often see that it goes kind of unrecognized by a lot of people, including, prospective students, that, the buildings that we're in are kind of taken for granted. And, their design as far as keeping them up and standing is taken for granted in cars and things like that. But going back to materials, I mean, as you said, materials are everywhere, and people don't really think about all the materials they're interacting with day to day.
It's a lot of,
And I mean, the same goes for my Department of Energy and Mineral Engineering, where you often don't think about what keeps the lights on and how we're getting our energy and what it's actually doing for us and what it all takes to get energy out of the fossil fuels or solar panels or whatever it may be to keep society going, right? So
yeah, it's a very good point. Anybody watching or listening to this is doing so on some device that required some degree of energy and some advanced materials as well. You think about the stuff that goes into the touch screen on a phone to allow it to actually function in that manner. I mean, we're sitting in the podcast studio now with all this, nice acoustic foam on the walls, which is a very intelligently designed material. Incorporates a decent amount of carbon, polymers. It often has small metal, either like tungsten or titanium spheres in there as well, because it's supposed to absorb a wide frequency range of sounds. It's I like it just because so much versatility, because I was the sort of person, I never really knew what I wanted to do. I now found that teaching is in fact what I really like to do. But it took me, until I was like maybe 28, 30 to figure that out. Which is still pretty good, honestly, to figure that out that early. But I in college and grad school even, I still didn't really have a strong direction, I would say. And so I liked material science because it just kept all those options open. I was like, well, I can just go into any other science if I want to, or I can stay here. And so at least, there's also plenty of undergrads in our department that are very clearly driven and already know exactly what they want to do, which is great. But I find that for some of the ones that are a little more like me, it works well.
Yeah. Is there a theme? Like what do students in your department want to do?
All sorts of stuff. There's the big general split, when they get to graduation, do they want to go to grad school or industry? And so that varies by year. For instance, this year's seniors, honestly, they have a surprisingly high grad school ratio. They're a very driven group that want to do their own research.
Like how many?
They want to lead their own
in your
research.
department go to grad school?
I don't know those numbers off the top of my head. For the seniors, I think their year is probably pushing like 30 to 50% of them are at least applying or going to grad school. I'd have to check that, but they're very very good group. I know some of them. One of them's committed to Caltech. One of them's between Berkeley and Northwestern. One's committed to MIT. One's committed to Santa Barbara. One of them's committed to Carnegie Mellon. So, they're doing a really good job.
Is that because grad school, either a master's or PhD degree, is needed for a lot of careers that they're thinking about?
No. I would say in material science, you can very easily just go straight into industry, which is what the majority of our undergraduates usually do. Yeah. I mean, some of the recent ones, one went to Corning this past fall. One's at the Applied Research Lab here at Penn State. One's taking a job at a steel plant, Carpenter. They do a lot of metals design, things like that. One of them's at Sherwin-Williams Paint Company. So a lot of them go straight into industry because, it's a very good opportunity, but a lot of them really want to do and lead their own research. So in order to do that, you want the doctorate, to sort of facilitate your own ideas. And I imagine a lot of them will be going into industry. After that, some of them might go for academia or government as well. But it's been nice to see. I've been really happy with what they're all up to. It's a surprise. It's a very good group, and a lot of the underclassmen are following in those footsteps. Much like your department, we try to set them up in research and get them well prepared. At least ideally 2 to 3 research experiences in undergrad if they can get it.
Yeah.
So. It's nice.
Yeah. I mean, my department, we get a lot of undergrads doing research, but then the lure of the industrial paycheck.
Sure. A lot of ours go to that
sweep
too.
aside to go to grad school, so they do some research because they like it and they get a nice skill set out of that. But then they inevitably end up going off to industry. So we don't get a large percentage of students in energy and mineral engineering going to grad school, but our majors are much more kind of industrial oriented. So. Just for starters, so in the Department of Energy and Mineral Engineering, we've got 4 engineering majors on our roof. So we have environmental systems engineering, we have energy engineering, we have mining engineering, and petroleum and natural gas engineering. And then we have a 5th major that is not engineering. It's energy, business, and finance, but that's for a different podcast. So those different majors, I mean, our graduates go off into different companies from those majors by and large. So for example, with petroleum and natural gas engineering, a large employer and recruiter for that major is Chevron. So get a good number of grads going off to that company, as well as like Shell. We have smaller companies that are based in the Marcellus Shale play, like Range Resources and EQT that hire grads. We actually in that major we have a good number of sponsored students, so they already have kind of employment lined up. They tend to be international students, so pretty much it's like Saudi Aramco is the big sponsor for students.
Yeah, we have a bunch of students that they sponsor as well.
Yeah. And then we have for mining engineering. Companies like Consol are a big employer. Pretty much any mining company that's operating will hire our grads spot on because there's just a huge demand in that area. Like our students have no problem finding jobs. So we can't graduate enough students to meet industrial demand in that area. So, and then in energy engineering, there's just a whole plethora of companies that hire energy engineers because that major is so diverse. I mean, we teach solar, we teach wind power, we teach hydropower, we teach batteries. So as a matter of fact, Tesla is a big employer of our grads just because of the battery aspect. I mean, that's really what Teslas are about, or having efficient, energy-dense batteries. So they hire a good number of our grads, and then companies like GE, consulting companies like Accenture hire grads for energy engineering, and then environmental systems engineering. That major is all about remediating industrial pollution, and to a lesser extent, worker health and safety. And so we get our grads from that a good number go work in industry for companies like Chevron or any other companies for that matter, Boeing, et cetera, et cetera. But then we also get a good number who go and work in government as well. So either kind of municipal level government or state level for the most part. And then in that field, we do get a healthy percentage that go off into grad school too. So,
Yeah. Yeah, a lot of opportunities just overall.
Yeah, exactly. And our college does a good job of bringing in recruiters too. And
yeah, we have our own career fairs,
yeah,
much as the others do. But yeah, it's been, I think, both of our departments prepare students well, which is Earth and Mineral Sciences is nice because it's a smaller college. So our departments are a little smaller compared to a lot of the more conventional engineerings, and so one of the advantages is we both still have a pretty sizable number of faculty. So a lot of our undergraduates, at least in MATC, start research in a lab group like freshman or sophomore year. And so doing that, then they start winning more internships earlier because they already have experience. And then by the time they graduate, they have, multiple research experiences, which really sets them up for success. And you also, I know all my students' names because my class size, average is probably like, 20 to 40, depending on what class it is. And, some of the senior level labs and stuff I teach, I might only have 8, 12 students or something. So, you get to know them really well, which, helps us sort of tailor the educational experience a little bit and provide better advice. And you were saying how many of yours get jobs right off the bat. And, MATC's similar. I think over the last 3 years, 90% of our graduates have a job or grad school offer in hand at the time of graduation. And of course, many of the rest of them get that soon after, or some of them take a well-deserved break before they decide to move on, which is totally fair. But yeah, there's a lot of, there's, like you said, a plethora of jobs, I think is a good way to put that. We have a lot of opportunities for our undergrads.
Yeah. You were talking about research. What sorts of projects do undergrads in your department work on? I mean, I walk through Stidle and I see them all in
we have a nice lab
magnificent
space,
labs that they have, but I have no idea what they're doing. So.
So they work directly with the faculty that run research groups. Some examples of some of the lab groups that I know have a ton of undergrads. One is Dr. John Paul Maria's group. So he does a lot of work with high entropy oxides and ferroelectrics. So like right when you walk into Stidle and you see all those fancy steel chambers that are all used for vacuum deposition and things like that, that's his lab space. So really interesting research where they basically are fabricating their own advanced ceramics from start to finish, and doing a couple a week.
And what can be done with these advanced ceramics? Like what's the
so ferroelectric's very prominent in a lot of sensor applications, things like that due to their unique electrical and magnetic properties. A lot of the materials they're working on also have applications for like quantum materials because they'll have the ability to isolate.
Computing?
Yeah,
Wow.
So they do some development because one of the difficulties, quantum computing and quantum systems are a big aspect these days. And the physics, of course, even what a lot of the physics department is working on is developing materials that are able to isolate these spin states. Very interesting. Another lab group that I know. Some interesting research is that we have a number of undergrads in our department head, Dr. John Morrow's group. So they're working on the Lion Glass project, which you may not have heard of. If you watch the football games as I do, they actually have commercials for the Lion Glass project during the halftime. So it's fun. You'll see some of our undergraduates there. They made them look all cool with they're doing all sorts of like action shots and stuff. It's pretty fun.
But they are in fact cool, right?
Oh, they are. It's pretty neat research. I'm very jealous because they partnered with like Bormio Luigi for glass production over in Italy. So like the graduate students, and occasionally they're going over to Milan every so often, things like that. And I'm like, wow, that sounds fun.
Poor students.
Over to Milan. Some of our undergraduates, are working on that. They're part of that project. And so they're coming in and using the glass furnaces and fabricating these compositions and testing them for, okay, well, what's its vulnerability to corrosion? How's it going to withstand, this excellent environment, other, common factors that, glasses are going to have to deal with because it's starting to move towards production. They partnered, I think, with a liquor company, with a perfume company, and with a company in Pittsburgh as well that does actual industrial, glass for buildings and things like that. So
potentially $1 billion
who knows?
Company that
It'd be really cool.
result from that,
I'm
right?
excited to see where it goes.
Yeah, so we got a healthy number of undergraduates doing research in the Department of Energy and Mineral Engineering, and I'd say one of the nowadays kind of the prominent places where students are doing undergraduate research for us is in our Critical Minerals Center. So we have a research center devoted to critical minerals. These are sort of the necessary ingredients that go into all modern day technology, whether it's lithium for lithium-ion batteries, or cobalt, or neodymium for the magnets in your earbuds, things like that. So these are they're rare, they're hard to come by, but they're in high demand to get all modern day technology into your hands, basically. And so we have a research center that's focused on how to extract these critical minerals from the earth or recycled electronics from various sources. And so we have a lot of undergraduate students who are doing research in that center to find new, sustainable, cheap ways of getting these high demand materials out of either raw ore or from recycled e-waste, basically. So that's one example of undergraduate research in the Department of Energy and Mineral Engineering. Yeah.
That's a very good one.
Yeah.
Certainly. That's the area I worked in a bit as well, because I was all on rare earth recovery in my PhD. So it's very important. It's nice. You guys do a lot of really good work over there.
The big societal impact is, of course, alleviating these industrial bottlenecks on creating the latest, greatest technologies, whether, it's not just, laptops and cell phones and things like that, but it's critical technologies to make sustainable energy more realizable. So solar panels, electric vehicles, more efficient power plants, the batteries that go into turbines for wind turbines. It goes in everything. And so, if we don't have these raw ingredients to make these things, they're not going to get built cheaply. And so, it's really critical that we, have an abundance of these materials so that we can have more cheaper, sustainable industrial processes to get these critical technologies going. So, going back to materials, what would you say is the kind of big, broad societal impact?
Yeah, as far as a lot of our research is, energy is very important to us as well. Developing, again, you guys are working a lot on the designs and recovery and mining of them as well, but, we need these materials to build, we have research on, improved battery designs, all sorts of different aspects, improved sustainability for textiles, things like that. I remember we have a undergrad who's actually going to NC State, the top textile school for graduate school. But while she was here, she put on like a sustainable fashion show of a bunch of pieces that she made, and like did that down at the Schlow Library, which was really cool to see undergrads, get involved. It's, a very interesting stuff. We have a lot of folks that do work on, a lot of energy applications, I would say, much like your department. That is one of our stronger areas of interest, because energy is a concern, certainly from a world perspective. There's a lot of elements, like you're mentioning, that are, hard to come by, and there's, geopolitical situations that can make them even harder to come by, depending, on who has the largest, bulk of these resources in their own territory. And so, we try to work on ways to recover elements, recycle them essentially from devices or things like that that have been used, so that, we're less reliant on having to mine new materials, or looking for alternate materials that are more commonly available that can fulfill the same, necessary properties, so that we have another route potentially to avoiding those sorts of problems, as well as, trying to develop better grid scale energy, trying to push a lot of that technology forward so we can have better energy generation, especially with, a lot of push for data centers and AI and things like that. Energy consumption is not, we're not going to be able to meet demand basically for a lot of, projected energy consumption. And so we need to improve a lot of those aspects.
Yeah,
something both of our departments work really heavily on.
Yeah, and you mentioned sustainability. I'd say that's a big theme of our college, the College of Earth and Mineral Sciences. We not just in our departments, but all across the college. Faculty are doing excellent research, and we're teaching great courses that relate right to sustainability. So You mentioned some great examples there. I'd say, you might, in the Department of Energy and Mineral Engineering, you might think, oh, petroleum and natural gas engineering, that's sort of the antithesis of sustainability. But that same skill set is translatable to sequestering carbon dioxide in the subsurface. That's my research area. So capturing greenhouse gases and putting them underground so they can't warm the planet anymore. And also exploring, sustainable forms of energy. So we have Nelson Jade in our department who does, he's developing the latest and greatest solar panels, which has, I think he's got a really good synergy with material sciences and engineering, because it's really the materials in solar panels that are going to make them more efficient and, make them cheaper and more easily to put on your roof, basically. So
we have a number of folks working with like organic photovoltaics, so you get the flexibility or the ability to weave them into fabrics, or all sorts of different options for that sort of stuff. So there's it's a lot of research pushes going on there, and we try to offer a lot of classes that sort of enforce that sort of those themes as well. Like I know Dr. Hickey, Rob Hickey, runs a class on like sustainability and polymers, things like that, not only in the actual final products, but the synthesis and all that sort of stuff, which is a really interesting course. Yes, as far as collaboration goes, I mean, our department works very heavily with a huge number of other STEM departments and even some non-STEM departments on campus. We have sort of a 3D printing program that's in conjunction with mechanical engineering. We have the Quantum Institute that works heavily with, physics. We have a lot of people focusing on biomedical materials and things like that. So we have a lot of crossover with BME as well as chemical engineering. It's more interesting one. We do interface with architectural engineering a good bit, because obviously different materials are important for structural designs. Working on things like concrete and steel and all that sort of stuff. We even had an undergrad that was doing some little cross research with anthropology, because they often need to characterize to date a lot of the stuff that they find, and of course we have the equipment to handle that sort of stuff. So we can help them figure out what an artifact is made of, even non-destructively. We can examine these things with a lot of the tools we have. So that it gives us, I think, a wide range of departments that are interested in collaboration, and it makes for fun experience.
Yeah, we have in our department there's collaborations with civil engineering, geology is a big source of collaboration, especially with mining engineering and petroleum and natural gas engineering. I mean, understanding the geology of the rocks that hold these critical minerals is very important. We have collaborations with folks in IST, which I imagine people in your department do as well.
Yeah, we have the ICDS.
The rise of AI and computational power is really important for discovering new materials, right? What else? I mean, we have a faculty member who has a joint appointment with chemical engineering, so so there's that bridge there as well.
We have a few joint appointments with mechanical, chemical, nuclear, all those sorts of ones.
So that's not uncommon to have faculty members that are already spanning two disciplines. So.
Yeah, it's definitely. I mean, Penn State's a real collaborative place, and a lot of the departments, we work together. We use each other's instrumentation and expertise to, help push a lot of research forward. It's nice. Everybody's really easy to work with.
Do you get a lot of students in MATSE who know they want to do material science and engineering, or how many are?
That's a good question.
Coming from other areas.
So we have a pretty I think a lot of them actually now really do come in wanting to do material science and engineering. We do have a decent number that will still transfer from other engineerings. Often, I think a lot of times chemical engineering has been one of the larger feeders, which is a very good program, chemical engineering. I'm not knocking them in any way for taking their students, but I think a lot of times people think, oh, I really like chemistry and I really like engineering, I'll do chemical engineering. Actually, what you probably wanted to do is material science and engineering. It's just that fits that sort of blend of natural sciences a little bit better. Chemical engineering can be very fluid and process heavy, whereas we focus a lot more on, not that we don't also do fluids to a degree, but we're a lot more focused on like solid materials, things like that. So there's a lot of overlap, but we do get some transfers from other engineerings, and oftentimes people our biggest opponent usually from like a recruiting standpoint is just that people haven't heard of material science and engineering. They've heard of mechanical, they've heard of chemical, they know these things exist. And so then they find out about us and they're like, oh, actually this is much more in line with what I want to do. And then they transfer in. or do the minor. We have a nice Math C minor as well. So
yeah, sort of the way that Penn State's structured with the different colleges makes our majors a little tougher for students to find, I think. And students in general, like talking with high school students, like they're interested in engineering, and they think of sort of the classical disciplines in engineering, like mechanical and civil, and then and so naturally they get drawn to the College of Engineering, but they don't realize that there's some great forms of engineering outside of the College of Engineering, like energy engineering and materials and science and engineering. And
and both of our majors often at other institutions are in the College of Engineering. We just grew out of Pennsylvania's history here, which is why we ended up in Earth and Mineral Sciences. Pennsylvania's strong background in mining and processing, ceramic, all this sort of stuff. So
so Penn State's a big university, a lot of breadth, a lot of different disciplines available, and especially when you consider the other campuses that we have to offer. And so it can be hard to find your home as a student of where you want to be. So I've heard admissions has a great tool to solve that problem, this Find Your Fit tool. So check that out if you are considering coming to Penn State.
Yeah, I remember they demoed that for us, and we got to click through it and see how our majors pop out of it based on how people ask questions, which was pretty interesting.
And I found it's really helpful to talk to current students too. I think having these various events like EMEX and Spend a Summer Day and things like that, we get prospective students coming in. I think a lot of the value they get out of that is talking to the current students to see what it's like at Penn State, what the majors are like, what are they doing. So there's
no better advertisement for our department than talking to our current undergrads. So they're doing a great job, and seeing the things that they're doing firsthand and having them explain their research and talk about the classes they're in really is it's great. So you obviously you're going to go to college. It's decent financial commitment. You want to make a informed decision on that sort of stuff. And I also encourage, just another plug, I suppose, if you're, thinking about getting involved in STEM, a passion for that, you should consider applying to the Millennium Scholars Program as well here, which covers a lot of STEM majors. It's a program designed for students that are aiming for a postgraduate, like a PhD or something like that in STEM later on. But it's a very good program, and provides a lot of financial aid. And our college and departments also do provide financial aid to students based both on academics and merit. So, that's also a good opportunity that, will be provided, certainly.
Yeah, we hand out a lot of scholarships.
Yeah, we do. It's nice.
Well, so you were talking about students who transition into material science and engineering. So how, if they don't know that they want to do that right off the bat, how are they preparing to, what skills can they pick up to make that transition easier to get into engineering, I guess?
That's a very good question, because oftentimes, if you're coming from another STEM discipline, it's usually pretty easy because a lot of your freshman year is going to be the same fundamental physics, chemistry courses that we'd make you take anyway. But coming from a completely different discipline, there's a little bit of catch up to do potentially, which, we are able to assist with some summer classes and things like that.
Yeah.
But for students that are, trying to find out if this might be a good field for them, at least, we do have some lower level classes. Like I actually just created a class that debuted this spring called History of Materials Development. So that's an inter-domain class. It's not just for STEM majors. It kind of combines history and
so they can
science.
Check off some gen ed.
Yes, they can check off one of the gen ed requirements for an inter-domain. And if, they're like, oh, this class was really interesting, then maybe material science is for you.
Yeah, I think transitioning in our majors, it's helpful that, pretty much all the engineering majors at Penn State start with the same foundation of math, chem, physics, maybe bio, depending on the discipline, computer science, maybe an econ class. So, if a student has any strength in math and science, I think the transition, at least in those first 2 years, is very doable.
Oh, yeah.
Yeah.
Yeah, and for students that find out later along, I have a lot of chemies and biomeds that take my intro to material science class, but they usually take it as juniors. And I get a lot of them afterwards that are like, yeah, I wish that I would have done material science, which is, they're pretty far through their degree. So I always tell them, just pick up the minor. It's only 18 credits. You already just did 3 of them. And you only really have to take 3 more classes to get the minor at this point. So, a lot of them end up doing that. And then they use that to take some materials classes and bolster their own, degree. And plenty of our majors, will do a minor in another STEM major as well to sort of broaden their horizons, or just a completely different major. And we have an undergrad who's triple majoring with English, music, and material science. So
Triple majoring. Wow, you don't see many of those students. Huh?
Yeah, a student after my own heart there. So yeah, it's always nice to see, and we have some that will double. I've seen other ones that double in music. A lot of musicians, a lot of Matsies in the blue band. I think they just kind of propagate there, which is funny. But yeah, there's a lot of ways to gain exposure to Matsi if you're curious about it. And I think some of those intro level classes, like my interdomain or taking a Matsi focused seminar course, are a good way to test that out as a freshman and might not be sure about what you want to do. So
yeah, great. And do you see students gaining a lot of good skill sets and experiences from internships that they do in Matsi? Or for starters, like what kinds of internships do Matsi students do?
Oh yeah, so our students, most summers they'll either go to industry. So some of them will do internships often at local Pennsylvania, industry. Like one went to a ceramics refractory company, went to like a metals plant, things like that to get some hands-on industry experience. Some will do REUs at other universities. So they'll go places like.
Oh, nice! I did REU.
That's great.
It's a lot of fun.
Yeah, so they go like Berkeley was a recent one, Caltech. Some of them go to Michigan. All the campuses offer REUs. Students come here to our campus for REUs. Some will do internships at government labs, so places like NIST, Argonne. There's dozen plus national labs scattered, more than that actually, scattered throughout the U.S., and most of them offer summer programs. So students will apply to those, and some stay here and keep doing research in the group that they're doing in the hopes of getting a paper, getting their name on something, things like that. So very wide variety of possible internships, and we always encourage them to do something. I teach a technical writing class that replaces English 202C for Matsi specific, and you guys actually take it too, so you guys allow that. So I get a lot of energy engineers there, which is great. And so I help them develop resumes, cover letters, personal statements, things like that to help prep them to succeed in that area. Where do you see where do you see a lot of your undergrads?
One thing I was going to say is that I think students get a lot of value out of internships for their lifelong career.
Yeah.
Like it's almost critical or necessary to have an internship in some of our different disciplines, especially petroleum and natural gas engineering, because that's really your foot in the door for employment when you do eventually graduate. And so, many of the interns from my department do work with companies over the summers. So for example, in petroleum and natural gas engineering, they'll maybe intern with Range Resources, which is a Pennsylvania company.
Sure.
I'm trying to think of some other examples, but yeah. But inevitably, they find that those internships not only give them a good understanding of how those sorts of companies work, but again, it's their foot in the door to get future employment.
Oh yeah, I totally agree. And it's one of the reasons we push internships and research so much, because I always tell my students in my technical writing and professional development class, 80% plus of people that get a job knew somebody there or had been there before. So a lot of our graduates, they go to the company they interned at because the company, it's low risk for them. They're like, oh well, this person already was here, they did a good job, they worked out, of course we're going to hire them, as opposed to somebody else. So it really does improve a lot of that sort of stuff. So yeah, it's like it's great to see students getting involved in those sorts of programs in both of our majors.
Our college, we have a staff member who does recruitment efforts, so he brings in companies that offer internships to our students, as well as my department also has staff who helps bring in companies to interview students for internships. So we're bringing those opportunities directly to students by and large. I think, students have found that the big career fair in Bryce Jordan Center is a bit overwhelming. It's great to have that, and, they might find opportunities that they didn't think of there, but it's often hard for them to connect with the companies that are most pertinent to what they're interested in, just because of the scale there, which is, it's impressive that they even do that, but we do try to, give them more relevant opportunities, within our own departments. So what do you guys do as far as
similar. We'll have a Matsi career fair usually the same week, and specific companies that want to hire Matsis will come to that. So it's a lot more intimate. Students can talk more. And the big career fair is great. I get my students in the the professional development class extra credit if they go to either of the career fairs,
nice.
just because I think it's important to get that exposure. But at the big one, it is a lot more hectic, and it's harder to pinpoint which companies might really be interested in you. So yeah, we do sort of similar aspects. We put together panels and things like that as well through GEMS or our external advisory board. We bring in some industry alumni from MATC, and have them talk to the undergraduates. Undergrads can ask questions, get advice, things like that. Because obviously, a lot of us are kind of academia minded, so we're like, they're good. It's like we want to make sure we're appropriately, exposing the undergraduates to industry as well.
Yeah, great. Well, I feel like I learned so much about MATS, even though it's right next door.
That's true.
There's all these details that we rarely get to talk about. So thank you, Dr. Smith, for sharing those insights on material science and engineering.
Yeah, I appreciate getting to chat with you as well, because we've had a lot of collaborations with energy, engineering, and mining, and we have you guys' test mine is in our building, so I always walk by it and I'm always like, oh, there's their mine. Whenever I give tours, I'm always showing people like, hey, energy and mining engineering's got this test mine here for ventilation systems. It's really cool. I snuck in there once. It was pretty neat. I think our departments have a lot in common, and it's nice to hear about what you're doing and what your undergraduates are up to, because they're always an impressive bunch.
Yeah, well, thank you.
Yeah.